Hey, in this video we are talking about for loops in C++ programming, and this covers sections 5.6 and 5.7 in the Gaddis book. So this represents the third of our three looping structures. We've seen while loops, we've seen do while loops, now here's the third one, for loops, which are specialized for a particular unique purpose. So the for loop structure looks like this. You've got a keyword for, and then you have parentheses with three separate parts separated by semicolons, and then there's the body of the loop that's being controlled, whether you repeat it or not. So the for loop is specialized to put together, to package together all the elements of a count-controlled loop specifically. At this point, we've seen count-controlled loops, where you know how many times it's going to happen in advance. We've seen user-controlled loops, depending on whether the user says Y or N, whether they want to go back again. So count-controlled loops happen enough that we like a structure here to make it very short for us to write. If you remember the first time we saw a count-controlled loop, we were using while, and we had to make a number. We had to make a variable number started at 0, and then the while test was, is number less than 5? And then the body of the loop would do something and then increment the number so it would count upwards towards 5. So initialize a variable, test it, and then increment it. So those are the key parts of a count-controlled loop. And basically, the for loop packages together exactly those three things. The first part is the initializer, what you start at. The second part is the test, what you're going to end at, really. And the third part is the update, probably the increment that we saw right at the end of the while loop that we were using as a count-controlled loop. So really, this first part happens before the loop ever occurs, right? Pre-loop, you perform this initialization, probably set your variable to 0 or whatever you're starting at. Then you check in on this test, which is like the while expression. If this is true, then you're going to go down and do the body of the loop, here, the single statement. Again, that could have been a block in curly braces. Once you do that body, once you do that statement, then you come back to this third part, then you do this update, which is probably the increment, similar to what's at the end of the while loop. That's the third thing. And then you go back to the test. And if that's true, you do the statement, and you come back to the update. And you go test, statement, update, test, statement, update, until the test becomes false. And at that point, you skip over the statement, and you go on with the rest of the program. Okay, so you're probably going to see the starting number in the initializer. You're going to see the ending number in the test. And it's really handy to see all that stuff together, controlling the for loop. And this is probably how most of us actually write count-controlled loops, because it's shorter and just more readable and easy to see in one place. So that's why we like this. Here's a flowchart for a for loop, and you can see again this is just going to be one line, plus the controlled statement. We're going to see this in the next code sample. So the initializer happens first. You hit a for loop, you hit a for statement, and the initializer happens first. And what you're going to see in this example is num equals min number, like maybe 0, possibly, for the start of it. Then you go to the second part, which is the test, and we're going to see is num less than or equal to the max number, which I think in this example is 10 for what it's worth, right? If that's true, then you go run the body of the loop, and in this case, it's going to be display the number and num times num, which is the square of the number. See, the point of this program is basically to print a list of square numbers. So you do num times num to get the next square. Once that's over, then you go to the third part of the for statement, which is the update, and you will be incrementing num, which of course is a plus plus, right? And then you go back to the test, right? And you check, is num less than or equal to max number again? If so, do the printing body. Then you come back to the third part, which is the update. And then you go back to the second part, which is the test. As usual, at some point, that test is going to become false, and then you can go on with the rest of the program. If it doesn't become false, infinite loop. So try to make sure that doesn't happen. So here's that program from the flowchart. This is program 5.9, and the goal of this program is to display the numbers 1 through 10 and also their squares. So start off declaring data. And you make constants for these mixed numbers. The min number is 1. The max number is 10 here. they're making a variable for the counter. This num here, which is an integer, is the counter, and it's going to go across the loop. It's going to go 1 and then 2, 3, 4, 5, 6, 7, 8, 9, 10. Print a header to this table that we're trying to get. So number, and then here's the number squared, a little underline, which is nice. And then a very small amount of code, right? This is why we like the for loop, because it's very short to write. The initializer is set num equal to min number, which is 1. The test is keep going while num is less than or equal to max number, which is 10. Right? As long as that's true, you run line 16, which prints out number and 2 tabs. Remember, \t is the escape character for a tab to give you some space on screen. Another alternative that would be smart would be to use set w, use set width to state exactly how much space you want the next number printed in. That would have been another option. And then you print out num times num, which is the square, and then an end line. Right? And then you come back to the third part of line 15 where you increment number, and then you go back to the second part. So you're on line 15 and then 16 and 15 and 16, 15 and 16 until you've counted up to 10 and the program ends. Here we're going to test this program 5.9, our first for loop here. And again, the goal of this program is to display the numbers 1 through 10 and also their squares. So I'll compile this. Looks good, and I'll run it. And there it is. Okay, the label's up here. So you have the number 1, 2, 3, 4, 5, 6 up to 10, and here is that number squared. So obviously 1 squared is 1, and 2 squared is 4, and the next square is 9, 16, 25, 36, and so forth up to 100. I'm pretty familiar with this because when I teach algebra classes, it becomes important at some point that you know your square numbers when you're factoring and stuff like that. So that's what was expected here, right? We knew there were going to be 10 things in this table, so using a for loop to count as num goes from 1 to 10 was a pretty smart way of doing this. If I want to see a larger table, no problem. I want to see the squares up to 20, right? Just change this constant here on line 9 to 20. And I can recompile, and I can run this, and great. Okay, so now the table goes from, so 1's up here, goes down to 20. And you see the squares for 16, 17, 18, 19, and obviously 20 squared is 400. You want to see the squares up to, 100? No problem. So there's all the squares all the way up to 100, and that's still taking less than a second for the computer to do that, to about 2/10 of a second. I wonder how far I could count in 1 second, like maybe 5 times as big. Maybe I can make the table go up to 500. Okay, that only took half a second. Interesting. So I just printed, right? If I scroll up, I'm going to see every single number and every single square from 1 to 500. So I guess maybe I can go up to 1,000. Sometimes I just get interested in like how fast, what the speed is of the program. So now I'm doing all the squares up to 1,000. Geez, that still only took about half a second. Interesting. So it seems like as my processor sees what I'm doing repeatedly, my processor is smart enough to start accelerating that in certain clever ways. So even if I count up to 1,000, from 1 to 1,000, it still does all this math in only about half a second. Pretty clever. Okay, but as usual, what I want to do here is we know that our processor is very fast, and that's what computers are for. But I want to make sure that we really understand exactly what's happening with our for loop. One thing I'll say is, this is me changing that is part of the reason why we use constants at the top of our program. Is I don't have to hunt. This is a little cryptic down here. If I put the number here, I would have had to kind of hunt for what number to change in the for loop. And it's really better to have that very visible near the top of the program. And then I can just change the constant and the program follows through according to what I wanted. So this makes a lot of sense if you have a fixed number to make it a constant. So if you do have to modify it later on, it's easy to spot. So I like that. One thing I don't like is I don't like these end-line comments. And you can see as I was adjusting this number to 1,000, right, these end-line comments used to be lined up, so nice and so clean. But as soon as I modified that, now the end-line comments are out of sync. And then I would have to start wasting time. Okay, well, now I'm going to move this one over here to line them up. And then when I go back to 10, I go, okay, now I got to line this back up over here. So this is why I recommend not using end-line comments, so you don't wind up wasting time having to line them up like that. But the book uses them, and I understand why for beginning programmers, the very first time you see something it's trying to highlight, here's exactly what this is. Me personally, I would have ripped those out. But let me modify this to a smaller number, and I'll just deal with the fact that the comments are now not aligned. And let's run that in the debugger. So let me put a breakpoint on kind of the first interesting statement, which is the printing statement on line 12. And I should be able to start debugging it. And as you know, the program is currently running, but the debugger has paused it right before line 12. So I'm going to position my console here. Let's see, there's this variable num I'd kind of like to keep an eye on, so I'm going to add a watch for that. And you can see as the program starts up, of course, it's got random garbage, in this case 4,242,464. No, I could possibly predict that. Don't use it in a piece of arithmetic before it gets initialized. So now I can start running one step at a time here. So I'll run line 12, and it prints the labels. And I'll run line 13, and it prints the underlining. So now here we are in this for statement on line 15. Now, this is a little bit tricky here because there's actually 3 separate things baked into line 15. So what's going to happen here is the first part, the initializer, will happen, and you'll set num to 1, of course. And then it's going to proceed to the second part that's going to test, is num less than or equal to 5? That's going to be true, and once that's true, that will send us to line 16. So let's see what happens. Yeah, so num has become 1 because of the initializer, and the test, which was true, sent us to line 16. So now I'll step through line 16. It does a number of pieces of printing. It prints number and tab, and then the result of num squared, really, and then an end line. So I'll step through that. And where does it go once it's done, actually? We'll see. Okay, so printing this. Print the 1, print some tabs, print the 1 times 1, and now as we wrap up, it sent us back to line 15. Not a big surprise. But the real question is, where on line 15 are we in reality? And if you remember what we said, it actually sends us back to the third part. So it hasn't happened yet, but it sent us to the update. So the next thing that's going to happen is that num++ in the update will happen, and then we'll go to, hopefully you know, then we go back to the second part. Right, and it'll send us back to the test, and it'll check on and is, because num will be 2 then, is 2 less than or equal to 5? That's true, and that's going to send us back to line 16. Let's see that happen. Bam. Okay, so num became 2 because of the increment, and then the test was true, so it sent us back to line 16. So it'll print, right, print the 2, print some tabs, print 2 times 2, which is 4, and once that wraps up, it sends us back to line 15, specifically the update. So now we'll do the update, and we'll do the test again. We'll never do the initializer again. That only ever happens once. But now we'll just do update and test, and update and test every time. So I'll hit next line as this updates and tests. Right, so num became 3. The test is still true, so it sent us to line 16. And now line 16 happens. There's a 3, there's the 9, and then it sends us back to 15. And now we'll update and test. So num becomes 4. Still true, back to line 16, and we're printing, right? We're back on line 15. Again, updates to 5, of course. Is 5 less than or equal to 5? It's true, so of course it's going to send us back to line 16 again, right? And we're printing, got the 5, right? Now, when line 16 gets done, where is it going to send us next? Okay, same as other loops for what it's worth. Let's see. Well, it sends us back to line 15 again. Remember, anytime you do the body of a loop, of a while loop or a for loop, it sends you back to the loop controller again. We're back on the update one more time. So when I hit next line, num++ will happen, right? Num will become 6, actually. We'll do the test, is 6 lesser than or equal to 5? That's false. And then where will we go? What line number will we go to then? Okay, so obviously once that becomes false, you skip over the body of the loop and it just sends you directly to line 18. Now, a couple things about that. Notice that the goal of this for loop was, as you can see in the console, was to count from 1 to 5. You see in the printed 1, 2, 3, 4, 5. After this loop is over, look at that. Num's actually holding 6 because that increment bumped it up to 1 more, and that's actually what terminated the loop. That's actually what got you out of the loop. So kind of interesting that the variable is actually holding 1 more than you needed after the loop's done. And if you ever need that variable for something, you have to be careful that it's now 1 higher than you ever actually saw while the loop was running. So maybe be a little careful of that. Fortunately, we declared this variable outside the loop, because if we had declared it in the loop, then it would be out of scope now and it would actually be totally wiped out of the memory system. But we still have access to it, and it's 1 more than it used to be. So as usual, return 0 says, hey, Windows, there is no error. Everything's happening perfectly fine here, and the program is getting cleaned up, and now it's over. Great. So a pretty good example, looking in close detail exactly what's happening with a for loop there. Okay, so that's the basic for loop to do a count control type loop, and what we saw in that example is pretty much what you'll usually see. There's other slightly more exotic options for a for loop that we're going to see on this slide here. So first of all, the one thing that I do quite a bit is you can declare variables in the initialization. You can make it look like this. So previously we declared like num, our counting variable, before the for loop, but you could do it in the initializer. You see this? So the first part has now become int count equals 0. So I'm actually declaring a new variable count in the initializer, and I'm initializing it to 0 at the same time. So we do that a lot, actually. Why not? If this is where the counter variable is being used, why not declare it right here? Perfectly legitimate. So you put this all together, and I think you can guess this particular loop would print hello to the screen on 5 separate lines. It's really a much shorter version of our first ever loop, right? Our first ever loop printed hello on the screen 5 times, but we used a while loop and it took like about 6 lines of code. Here with a for loop, which is specialized for this, you can make it super, super short, which we like. Now, a couple notes about that. If you declare a variable, as we're doing here, in the for loop, it only has scope within the body of the loop. So once, and remember what scope means, is this is the place where the variable lives. This is where the place where the variable is accessible. So if you do what's on screen right now, once you get past this loop, once you get past line 6, the count variable does not exist anymore. It is wiped out of the memory system. So, and that's usually fine, because usually the only thing you want this for is just keep count that the loop is happening the right number of times. Occasionally, you want to check in on that later on, and if that's what you want to do, then you cannot declare it in the initializer. You do have to declare it before it if you also want it to be available after the loop. But if the only place you're using a counter is just in the loop, do it here, and then the scope is just limited to this particular piece of code, which makes sense. Now, in addition to that, you can do multiple initializations. Okay, if this first part I could separate with commas, I could say int, x equals 1, comma, y equals 5, comma, z equals 20. You could do multiple initializations. You can do multiple updates. So I could do x plus plus, comma, y plus plus, comma, z minus minus, comma, w times equals 10. All of those things are legitimate. It doesn't have to be plus plus here. It could be any piece of math, frankly, that changes your variable. I don't do that stuff a lot. Once in a while you might see that. It's kind of rare. Usually I just stick with one initialization and one update. You could have multiple separated by commas. And then in addition, you can actually, all of these things are optional. So any one of these 3 pieces, you could actually leave blank and just have blank semicolon something. Maybe some very clever, cunning programmer can make that work intelligently. I have never bothered to do that. If I'm leaving something blank, then I feel like I might as well just use a while loop and have it be more readable if I don't need one of these parts. Okay, so slightly more exotic options. You can see in the book, chapter 5, they have examples of all these different modifications to it. But almost, 98% of the time, this is what my for loop looks like. All right, what other interesting things can you, now that we have all three types of loops on the table, what kinds of interesting things can you do with them? Well, one job that you commonly have to do in a program is to keep a running total of something, right? Like all the bills in a day or all the, payments in a restaurant for the week. So the way that we do that, there's a technical name called accumulator. This is not very complicated, but it's called an accumulator. And an accumulator is a variable that is set up to keep a running total of values through a loop. Right? If you're repeating a process, repeating a bunch of bills or payments, that's probably in a loop. So you're going to make this variable for the accumulator, and it's going to appear in three places. Before the loop, you'll need to initialize it to 0. It's like having your cash register start at 0. Okay? If you forget to initialize it, the variable is going to have random garbage in it, and I'm sure that a customer at a store would be very upset if a cash register didn't start at 0, but started at $1,024 instead. Right? That would be obviously not right. So make sure that you initialize your accumulator to 0. It's something I see basic programmers forget about occasionally, and then like, why is my total thousands of dollars higher than it should have been? Because of the random garbage. So before the loop, make sure you initialize it to 0. In the loop, you're going to have an assignment statement that's doing combined addition assignment, right? It adds the next number into the accumulator, adds the next number. So every time through the loop, you add in one more number. And then after the loop, right, then that variable, that accumulator variable, will have the total and you can use it. You can display it, you can use it in another calculation, you can send it to another function if you want to, whatever you need with it. Okay, so one thing before the loop, one thing in the loop, and one thing after the loop. Here's an example of that. So here's program 512, which is a program that takes daily sales figures over a period of time and calculates their total. Pretty good example. This is actually something that happens quite a lot in our later work. So starts off declaring data. I call that step 0 usually. So there's an integer for the number of days that you have data. You're going to ask the user, how many days of data do you have? And then here on line 10, this is my accumulator, right? It's a double variable because it's money. It's called total, and it's being initialized to 0, just like we said we would. So there's the accumulator being initialized to 0. Sometimes, you can call it total, you can call it accumulator, you can call it sum. People, SUM for, the result of an addition. So these are all perfectly legitimate names for your accumulator. And then here comes the input part of the program. Prompt the user, how many days do you have sales figures? And the user will type in how many days, whether it's 5 or 30 or 60 or something like that. And then here's a loop, right? Accumulators are something that happen in a loop. This is a for loop. We're going to get the sales for each day and accumulate the total. So in this case, notice that we are declaring the counter variable in the initializer of the loop, right? We could have declared an int count before, but here we're doing it right here. In this case, we're setting the count at 1, and we're continuing as long as count is lesser than or equal to the number of days, and then incrementing every time we get past the body. Now remember, up until now, I think most people would make a count control loop. You start at 0 and you go less than the number of days. But this is actually going to do the same thing, basically. You're going to start at 1 and keep going while you're less than or equal to the number of days. Perfectly legitimate. Some people do it this way. It's going to be the same number of days if you think about it. The body of the loop is, here's a double to hold the sales just for this day. Prompt the user for that. Enter the sales for day, and as count goes 1, 2, 3, 4, you're going to see enter the sales for day 1 or enter the sales for day 2 here. User sends into sales, and then here's the thing that's happening to the accumulator on line 22 in the loop, right? Here's total plus equals sales. If you remember what that combined assignment symbol means, it means take total, load it up in the CPU, add in the number of sales, and then set that back in the total variable. So whatever total used to be, we've just added in today's sales. And you do that each time for each day. And then after the loop ends, you'll get down to the output part, line 25, and we're going to display the total sales. In this case, it says the total sales are $sign total. Okay, and there's total being used after the loop. And now we're going to test this program 512 here that has an example of an accumulator. And hopefully we understand what's happening there. Just entering a number of sales figures for a number of days and adding them up as we go along. So compile this, looks good. Close that, and let's see what happens. Okay, so it asks the user, how many days do you have sales figures for? And let's say, for this example, let's say I have 5 days, like maybe 5 weekdays. And then it says, enter the sales for day 1. You know, maybe I have a very small store. I kind of want these numbers to be small enough that I can do it in my head. Let's say I have $100 of sales on day 1. Enter. Right, enter the sales for day 2, maybe 200. Right, maybe on day 3 I make $500, and on day 4 I make $1,000, and getting better and better every day. Let's say I make $2,000 on day 5. Okay, and it says the total sales are $3,800. Okay, and you can do that in your head, right? The thousands add up to 3,000, and the 1, 2, and 500s obviously add up to 800 there. So that's correct. Looks like that's working correctly. And that's it. That's an accumulator. It does the job, right? So this accumulator right here, we initialized it to 0 before the loop. And that was important so it didn't have garbage data. We added each of those things that I typed in. As I typed in 100 and 200 and 300 and so forth, it got added into that variable. And then at the end, when you printed it out, it had the 3,800. Let's inspect that really, really close. I kind of want to see that in the debugger, just to make sure we absolutely understand what's happening there. So I will put a breakpoint, I guess, here maybe, might be interesting. And then I'll start debugging it. Hopefully I have enough space on the screen for this. Okay, and so again, the program is running, but it's paused right before line 10. Now, technically, line 9 isn't actually a statement at all. You know, it's a declaration, so there's a space in memory for days, but it doesn't really do anything. So we have gone on to line 10, and I do think I want to keep an eye on, I guess there's like 4 variables here, right? There's days. I kind of want to see all these things. There is total. Okay, and then further down, I see that we're going to have a variable called count. And there's also sales, which represents the sales on one single day. Okay, now there's a couple interesting things here that's happening. So first of all, the variables that are declared at the top of the main function, right, they exist, but they've got garbage data. So days is holding 59, and that double total is currently holding 1.862005 times 10 to the negative 307th power. Now that's some quality random garbage. And obviously, like if you had a cash register that started up with that number, something would be really glitched up when you start adding up, you know, additional sales figures. So that's why it was really important to initialize that on line 10 to 0, which is about to happen. But in addition, you know, the other variables, count and sales, which are declared further down here, they're not in scope. Remember, when we say scope means the part of the program where the variable exists and is accessible. So you can see that's showing up in red right now, and it says it's not found in the current context. Those variables just don't exist yet. And, you know, if I was on line 11 and tried to do something with them, that just wouldn't make any sense, and you wouldn't be able to compile that because those variables are not in scope. And the compiler would say, I have no idea what you're talking about right now. Those variables are not in my memory system. Okay, but they will be in a little bit. So I'll start doing this one line at a time, and obviously the very first thing is initialize the accumulator to 0. Bam. Okay, so total became 0 like you like. Now you're prompting the user, how many days do you have data for? Right, so there's the prompt over there. And here's the sin statement. So I'm going to say, for this example, I'm just going to say 3. And you can say 3 got into days, which is good. And now, let me see a little bit more of the code here. So now you're getting to this for statement. And you can see that count, right, gets declared in the initializer. So at this point, this is the first moment where count actually exists. And you can see that count is now in black, and that's actually a place in memory. And of course, it's holding random garbage. What is that? 1,911,120? Some kind of random number. So now we're going to start going through the for loop. And the first thing is the initializer will happen. Count will become 1. You'll do the test. And it'll check, is 1 less than or equal to days, which is 3, true, and then we'll start going through the body of the loop. Great. So count became 1. Now you hit line 19, which declares the sales variable. So now that actually exists for the first time. Random garbage just happened to be 0 in that case. Sometimes it's 0, but it could have been like 2 million or something times 10 to the 300th power or something. Just happened to be 0. Sometimes that happens. Now we're prompting the user for the first time, enter the sales for day, hopefully 1, right? Okay, so it just printed enter the sales for day. The end of that is going to print a 1 because that's count. Great. So enter the sales for day 1. See, it's printing for the count there. And now the SYN statement's going to happen, and it's going to wait for me to type in the sales for day 1. And I will put in 100 for that. I guess it's not happening yet. Happening now. Okay, so now I'm running into a keyboard buffer issue where the things I was typing were in the keyboard buffer waiting to hit the SYN statement. Let me just backspace that. Okay, so hopefully 100 goes into sales. Yeah, okay, so 100 went into sales. That's today's current data. And now we're going to run line 22, which is like among the most important lines in the program, because it's going to take total, which is 0, and it's going to add in the 100. Right, and it sends us back to the for loop. But the important thing is right this second, total is holding 100, the total sales so far, right? Now, we got, for what it's worth, it sent us back to line 17, which is the loop controller. We're outside the body of the loop, and remember, the sales variable only has scope in the body of the loop. It only exists from where it's declared down to the curly braces that end the block. So now on line 17, once again, sales doesn't exist right this second. It's not a thing. But we're back on the update, so what ought to happen now is count ought to get incremented to 2. Go back to the test. Is 2 less than or equal to 3? Yes. So that'll send us back into the body now with a count of 2. Great. So count is 2. Okay. Sales got created. It's got random garbage in it. Now you notice it just happens to be the first time sales started off at 0, right? It could have been anything. Now it just happens to be 100. And remember, that just happens to be the 100 that was sitting in those bytes that we typed in before, right? That's kind of an accident, kind of a lucky accident that the sales is using the same bytes and therefore just happens to be seeing the 100 that we used before. Now, that's not going to be the sales for today. We're going to prompt the user again, enter the sales for day 2, right? That's this count over here. Let me just take a look at that line. So printing enter the sales for day something colon is what we just saw there. And then we get to this SYN line. Hopefully I can get it to happen. And I'm typing in 200. Didn't happen yet. 200. Okay, and take a look at our variables over here. Kind of careful. I guess I have to enter, don't I? All right, so I hit next line a couple times, and this did a little bit more work than I expected for what it's worth. So when I hit 200, right, it hit this line 22, and it added the 200 into total. It used to be 100. It added 200 into it, and now total it's got 300, which is the running sum so far. And then after that, it went up to the for controller that I kind of blasted through. The update count became 3. It checked in as is 3 less than or equal to 3 true. So we're going through this body for the 3rd time now. Sales, the double sales was recreated. It's got this random number in it, which happens to be the number I typed in before. And now we're going to see enter the sales for day 3, because that's count. The sales for 3. Sometimes the debugger is like a little fiddly, and we're kind of running up against the boundary of what the debugger can handle efficiently. So now we'll be on this SYN statement. I'm going to type in 500 if it lets me. I have to hit it 3 times is what it is. And I think I'm just going to do this once here. Enter. Great. So you can see 500 went into sales, right? Currently total's got 300 in it. We're going to run line 22, and it's going to add the 500 into total, and hopefully you can see total ought to become 800 at this point. And where does it send us next? What line does it send us to next? Hopefully you know. Right, so total got the 800, right? It was 300, added in 500, now it's got 800. So it sends us back to the loop controller, as always at the end of the body of a for loop, specifically to the update. So when I hit next line again, count will get incremented up to 4. It's going to send us to the test. It's going to check is for less than or equal to days, which is 3, is for less than or equal to 3. That is false. And where is it going to send us then? Currently line 17, it's going to send us to line 26, of course. It's going to skip over the body of the loop and go on with the rest of the program. So at this point, right, total has got 800. Right? And at one point it held 100, and then it was 300, and then it became 800. And now you can set up your precision, and you can print out the total sales are $800. Great. And that's the correct answer, obviously. So I feel that's good to walk through what accumulator is specifically doing at least once. If you couldn't just figure it out in your head, that's kind of handy. Remember, this is a very key fundamental thing that you want to do with a loop, so you want to get accustomed to that. In the next semester of the course, for what it's worth, this happens in almost every single assignment every single week. It's like so fundamental. And again, the very first storage space on the processor is just for this, accumulator job. So a pretty key thing to understand about computing. And you tell Windows, yeah, everything's running fine, there's 0 errors, and you clean up, and the program's over. And that is a program with an accumulator. Great, so there's some stuff that you can do with for loops, right? For loops are specialized for the count-controlled situation when you know how many times it ought to happen as you get into the loop. It's not a user-controlled situation where you're asking yes or no to do something. We use for loops a lot. In fact, I might go so far as to say that for loops might be the most common loop that we use in programming, as a matter of fact. So I'm glad that we have it available now. And we also saw using accumulators to have a running total in a loop, which is a common task. And that's a pretty good place to be, actually. So at this point, with my students, we would do this lab here, where we have a program whose goal is to compute the mean, right? You could say average for that. Technically, it's the arithmetic mean of all the integers from 1 up to something that the user put in. So if the user types in a 6, the intention is what's the average of 1 and 2 and 3 and 4 and 5 and 6? And of course, that's defined by first adding up 1 plus 2 plus 3 plus 4 plus 5 plus 6. And that's the job of an accumulator. Right? So once you know the top integer that the user is interested in, you're going to have a for loop counting from 1 to maybe 6 or whatever, and you're going to have an accumulator adding up all those numbers, and then for the arithmetic mean, for the average, at the end, you'll take that total and you'll have to divide by how many you were talking about. Right? So that's how we're going to compute an average here. Now, if you know enough math, you may know there's a shortcut formula for getting that addition in one stroke. Okay? And then actually, if you think about this statistically, there's an even better shortcut for figuring out the average from between 1 and 6. But for practice purposes, we're going to pretend we don't know about that. And we'll get some practice with our for loop counting and with our accumulator keeping an addition to do it in a straightforward manner, just according to the definition, if we didn't know any math at all. So that's what happens on this lab. All right, so we have one more video dealing with loops in chapter 5 of the book. And in the next video, we're going to be talking about nested loops, about what happens if you take a loop and you put it inside another loop. And then maybe you take that and you put that inside another loop, right? What's going to happen with that stuff? And that becomes very powerful and gets to do a lot of job for us. So I'll see you then.